Welcome to Leveraging NVIDIA CloudXR 3.0 for Scalable Virtual Reality Training and Simulation. I'm your host, Jayson Pauwerss, Chief Creative Technologist at Brightline Interactive. Here's what we're going to go over today. I'll tell you a little about Brightline and myself and why we chose NVIDIA CloudXR. I'll tell you about the VR training solution we created with it and some key learnings and best practices that we picked up along the way. Okay, let's begin. Brightline Interactive has been around for over 20 years, riding the wave of technological innovation. We started doing augmented reality in 2008-2009 using FLAR Toolkit and Flash. We entered the VR space around 2013 with the Oculus Rift DK1, building out an in-vehicle distracted driving simulator for Toyota with sensors on the wheel and pedals and a gesture sensor to track the user's movements and translate them into VR, long before hand tracking became a thing. Since then, we've built out training simulations for a wide variety of government and commercial customers. In the early days, that was kind of it. You could build a one-off training sim and it would work well with one headset. It's only recently that virtual reality technology, game engines, and open standards have really progressed to the point where we've been able to build out an immersive training platform that can run on a variety of different hardware and UX types and scale up as needed. So that's Brightline Interactive. Who am I? I'm Brightline's Chief Creative Technologist, meaning I have the opportunity to vet new technologies and set our technology strategy. I've been with the company for 13 years and have had the opportunity to leap forward as each of the enabling technologies for cloud rendering came online. I'm super excited about 5G and CloudXR, and here's why. We've run the gamut of attempts to get wireless VR technology to work at scale. 5 wireless, TPcast, Oculus AirLink. And they've provided acceptable results, but the setup process and required on-site hardware for each of them was daunting. With 5G and CloudXR, that dream of popping on a standalone headset and immersing yourself in a high-complexity simulation may actually be becoming a reality. I was recently at a demo and I arrived with a backpack containing a hotspot, a Pico Neo 3, and a 5G-enabled tablet, and that was all I needed. Our first use of CloudXR was for a shared, place-based AR experience that was built and deployed in a retail environment for AT&T. One of the goals of the project was to allow users to interact with VFX-grade 3D models of movie props and characters. Really high poly, high resolution stuff, beautiful lighting, all of that was required. And in order to do that on mobile devices, we needed cloud rendering. The CloudXR software with its SteamVR pipeline on the server side and ARCore mobile integration on the client side was a perfect fit with a lot of the technologies we were already using on the project and the expertise we already had in-house. And so we were able to quickly prove it out and get it deployed into production. We learned a ton on that project, and it helped us see the value and the ease of integration so that we were able to push our VR training platform into the cloud as well. There are a ton of benefits to using CloudXR, but here are a few of the key ones that we identified while leveraging it to build the AR experience and our VR training simulator. First, reduced feedback loop. We were able to install the experience once and get feedback from dozens of stakeholders in a variety of locations. We were able to make changes live on the server and restart the simulator and get immediate feedback from those stakeholders. Second, scalability. And when I'm talking about scalability, I mean both vertical and horizontal scalability. So we were able to take advantage of a dedicated server-grade GPU, which allows much more complex scenes to run smoothly. And we were able to easily spin up and spin down servers on an as-needed basis, which allowed us to scale up horizontally as our needs grew. It covers both virtual and augmented reality. Being able to target VR and AR from the same workflow and pipeline allowed us greater content reuse, and allows us to engage with users no matter whether they're on a mobile phone or a VR HMD. This enables asymmetric multiplayer and a lot of interesting experiences between those two platforms. Seamless remote rendering means we're able to use the same build remotely on a standalone headset that we use locally on a wired headset. This is good for supporting a variety of deployment scenarios: cloud, mech, local, and offline scenarios. And lastly, and maybe most interestingly, back-channel support. So, one of the things that Brightline prides itself on is sensor integration. We've been doing it for a very long time, and we like to integrate things like microphones, accelerometers, Vive trackers, IMUs, Arduinos, and many others into our VR experiences. And CloudXR's back-channel support is an enabler for us to take those rich sensor interactions and push them to the 5G edge and beyond, enabling light client workflows that were never before possible. Now let's talk about what we actually leveraged CloudXR to build. Brightline has built an adaptive VR training simulator. Adaptive training as a feature set means training that can be modified to fit the needs of the student. In our case, that's instructor-led, so the instructor is able to tailor the training to the trainee in real time to maximize the effectiveness and stickiness of the learning. Scenario building is a key feature that I'll go into in a little more detail in a few slides, but basically, it allows a non-technical user to, on a 5G-enabled tablet or their browser, author customized scenarios using a deep library of content so that they can target specific situations or tailor the training for their trainees. CloudXR allows us to run on stronger hardware, meaning that we can build larger and more complex scenarios while still hitting frame rate. Using 5G, we've been able to achieve acceptable latencies without the hassle of navigating corporate firewalls. As 5G becomes ubiquitous, this will become even more valuable. Between the low latency and high bandwidth of millimeter wave 5G and the just-in-time reprojection of CloudXR, we've finally been able to achieve acceptable VR performance in the cloud over a cellular connection. The first time I experienced this was actually kind of mind-blowing to think that all I was using was a hotspot and a standalone headset, and I was able to interact with an incredibly complex training scenario. Last but not least, voice chat. Voice chat's a critical component of any instructor-led remote training scenario. And one of the new features of CloudXR 3.0, the audio back channel, and it enables our voice chat feature to work both locally and through CloudXR. This was a critical feature that we required in order to push our desktop-bound training system to the cloud. And so when it appeared in CloudXR 3.0, it was actually a pretty big enabler for us to be able to make this shift. Scenario building, as I referenced before, is a key feature and differentiator for our offering. It allows for full customization of the scenario, including basics such as location, weather, time of day, but also including more advanced per-scenario customizations, such as where users start, triggerable actions and audio clips, and objects and NPCs in the scene. Finally, the instructor is able to review their scene in 3D volumetric view to ensure that everything is placed as expected before jumping into the headset. The virtual reality training scenario system, what we call live control, is what allows the instructor to kind of drive the experience for the VR trainee. So on the left side here, you can see a view of the live control system with the ability for the instructor to control all aspects of the scenario, which had been set up in advance. And on the right side, you can see the trainee view, so you can see that they are in virtual reality, going through the experience, and that the instructor can see what they're doing live. Finally, after the trainee has gone through their scenario, the instructor is able to walk through an after-action review with them to tell them what they did right, what they did wrong. And there's a timeline associated with this that allows the instructor to be able to point out specific timestamps within the scenario where the trainee made a good decision or a bad one, and jump to those timestamps to specifically point out what the trainee did right or wrong. Here are some key learnings and best practices that we came up with in developing the applications that we developed with CloudXR. First, latency is a critical metric. We want to minimize it when possible, but NVIDIA does provide tools that can help with both minimizing and mitigating latency. Orchestration is strongly recommended to work at scale. Orchestration is going to provide you the ability to scale up and scale down as needed, as well as allowing you to control costs, because the virtual machines that have the heavy GPUs that you are going to want to use when using CloudXR will cost quite a bit, but you can control those costs by turning them on only when they're in use. And through orchestration, you can automate that turning on and turning off as needed. SteamVR has some nuances to it that we learned. The first is you can only have one headset or AR device connected to the SteamVR session at a time. This means it's basically a one-to-one scenario between the server and the client. Second, don't change your configuration during the session. If you have one headset type with one configuration, stick with that headset type across the board. If you're going to be connecting and disconnecting users, make sure that they all have the same configuration set up. Changing configurations during the session, such as changing the resolution that SteamVR is going to target, is going to cause a raft of issues. Lastly, SteamVR requires direct GPU access, so the virtual machine that you're going to run is going to need a grid driver, and it's going to need that direct GPU access. So make sure you follow NVIDIA's best practices and their guidance on which VMs to use. Lastly, and maybe the most important trouble that we ran into, that our new developers ran into when getting onto a CloudXR project, is handshake order. The importance of specifying the correct order to start your application can't be overstated. We strongly recommend automation to ensure proper handshake order, but I'll walk through it here just so that you have a good handle on it. The first step of the process is to start SteamVR. You can do this as your server boots up, or you can do this on demand. As the CloudXR server runs as a plugin to SteamVR, initializing SteamVR also initializes CloudXR so it can listen for connections. At this point, SteamVR still doesn't know what headset is going to connect, so it doesn't have a set FOV or resolution to output. If you run your VR content at this point, things won't initialize correctly. Next, you're going to want to run your CloudXR client. In the simplest use case, running the sample client for your platform will allow the CloudXR server to correctly configure SteamVR based on your client CloudXR startup options. At this point, if your user is in the headset and viewing VR, they will likely see Steam Home or the Steam Waiting Room. Finally, you can start the simulation. The VR user will see it load in SteamVR just as if they were tethered to a local workstation and will be able to jump into the content once it's loaded. For a more seamless solution, the CloudXR sample clients have source available on GitHub and are a good jumping-off point for creating a custom client and server solution that handles authentication, orchestration, handshaking, and loading in the correct content for that user. Because authentication and orchestration are outside the purview of CloudXR, they're left to your engineering team to customize. Thanks for taking the time to watch this talk, and I hope I've been able to teach you something today.